In this video, we're working on the 3D practice test for parallelograms. These first ones, we can see that the diagonals bisect each other. So that makes this a parallelogram. Number two, we have exactly one pair of opposite sides, and that's not enough to be a parallelogram. Number three, we have opposite angles congruent. That's a parallelogram. And for number four, we have a pair of sides that are parallel and another pair of sides that are congruent. That's not enough to be a parallelogram. They'd have to be both parallel and congruent, either two sets of parallel sides, two sets of congruent sides, or one set of sides that are both parallel and congruent at the same time. Okay, let's look at number 5. Now for this, they want us to tell if we have a parallelogram using the slope formula. So if I switch over to the graph paper, this is the one that goes with number 5. What we want to do is find the slopes for each of these segments. So slope is change in y, or change in x. The slope for PS is 1 over 3. The slope for FT is 1 over 3. So those are parallel. Now these other sides have to be parallel too for it to be a parallelogram. The slope of PF is, in terms of the y's, is 1, 2, 3, 4. And in terms of x is 1, 2, 3, 1, 2, 3, 4. It's a negative 4 because it drops down. So it gives us a negative 1 for the slope. The slope of ST is in y 1, 2, 3, 4. So that's 1, 2, 3, 4. And it's a negative because it drops, which is a negative 1. So both of these opposite sides are parallel. Yes, it is a parallelogram. For number 6, switch colors. For number 6, they want us to use slope and distance. So if we have one pair of sides that are both congruent and parallel, we can say we have a parallelogram. So I'm going to find the slope of YM. I'm going to find the slope of RO. They need to be the same. So let's see what. So we have a 2 over 1, 2, 3, and it's a negative. So negative 2/3 for YM, and the slope, or for RO rather. Let's see if that's the same for YM. We've got 2 for the Y, and 1, 2, 3 with a negative because it drops. So both of these are parallel to each other. So we got that. Now, if they're both also congruent, we have a parallelogram. So we need to find the distance between these two. So the distance formula is the difference of the x's squared plus the difference of the y squared. And we add them together and take the square root. That's the distance formula. So from R to O, we're looking at the difference of the x's squared. We've got negative 2 take away 1 is a negative 3. This is the distance R O. We've got a negative 3 to take the square root of a negative 3 squared plus. We've got to do the same thing for the y's. 5 take away 3 is 2. So we got 2 squared. So 9 and 4 makes square root of 13. Now let's find the distance YM. YM, do the difference of the x's. Negative 3 take away negative 6 is negative 3 plus 6, which is 3. So we got 3 squared. And negative 4 take away negative 2 is negative 4 plus 2, which is negative 2. So we have negative 2 squared. Negative 2 squared is still going to be positive. This also gives us square root of 13. So we have both pairs of opposite sides congruent. They're both root 13, and both are, or at least that one pair, is parallel and congruent. So that makes it parallelogram. So it's going to be a yes. Let's go to number 7. Here. For number 7, if these are parallelograms, the angles are going to be congruent. So we set 5x minus 29 equal to 7x minus 11. Add 29 to both sides. We're going to end up with a positive 18. And take away 7x on both sides, we end up with negative 2x. Add 29 to both sides, we end up with 18. So we get negative 2x's is 18. X equals negative 9. There's something wrong with that, so let me go back. It didn't seem right when that negative came out. Sometimes negatives do come up. It's not going to work with this one. So let me make this larger, have more room. So we got 5x plus 29 equals 7x minus 11. Take away 29, take away 29, minus 40, and take away minus 2x's is minus 40, x equals 20. And for the y part, 3y plus 15 has to equal 5y minus 9. Take away 5y from both sides, and take away 15 from both sides. Divide by negative 2, y equals 12. So those are the x and the y that make number 7 into a parallelogram. For number 8, the segments bisect each other, so their pieces are congruent. So we've got negative 4x minus 2 has to equal minus 3x plus 4. Add 3x to both sides, minus x, add 2 to both sides equals 6. Add 3x to both sides. This is a minus sign, so x equals minus 6. So negative, yeah, that's going to work out. Yeah, go ahead. Looking at the x's, or looking at the y's rather, 3y minus 5 equals 2y plus 8. Add 5 to both sides, we get 13. Take away 2 y's from the sides, we get y is equal to 13. So x negative 6y 13 makes this into a parallelogram. Let me bring this back in so we can see it. So it's just one that we just did. So negative x, so x is negative 6. It's still going to work because you get a positive 24, take away 2. This gives us a 22. And this gives us 18 plus 4, which gives us 22. So sometimes a negative does work out. Let's look at number 9. Number 9, opposite sides are going to be congruent. So we have 6x equals negative 4x plus 6. Add 4x to both sides. 10x equals 6. This is negative 6x. Add 4x to both sides. Negative 2x equals 6. Divide by negative 2. X equals negative 3. This can give us an 18. This can give us an 18. So that works. And doing the y's, 7y plus 3 equals 12y minus 7. Take 12y away from both sides, minus 5y. Take 3 away from both sides, equals minus 10. Divide by negative 5, y equals 2. So those are the numbers that will make that into a parallelogram. And then for number 10, these are equal to each other. So negative 2x plus 6 equals x plus 12. Thank you. Take away 6 from both sides, and take away x from both sides, minus 3x's equals 6. Divide by negative 3, x equals negative 2. That gives us a 10. and a 10, so that's going to work. And then for the y's, y plus 23 equals negative 4y minus 2. Add 4y to both sides, 5y. Take away 23 from both sides equals not minus 25. Y equals negative 5. Negative 5 equals 18 and 18. That works for those. Okay, last one. The pattern shown in the figure is supposed to be regular polygons or congruent parallelograms. What we need to do on this is see that they have the same slope. So you could kind of take a ruler and just kind of slide it along and make sure that they're all the same slope that way and the same slope that way. What else could we do? Make sure that they're parallelograms. We could try folding these diagonals on a bisect. That'd be the simplest thing I could see, would be to check that opposite side look parallel. Maybe with the ruler. So I could theoretically take a ruler, match it here, and then kind of slide it down here, slide it up there, and then you could do the same thing from this other side. Like we're going to ruler down through here like this, and then slide it sideways. And see that they all look like they're at the same angle. Same angle, same slope. So we really want to check the slope.